All right, we're getting into the concept of specific heat. And this is a very important concept that has many applications, whether it be to particle science, to weather and climate. So it's really important. And it is one of these things, specific heat, technically is the amount of heat needed to raise the temperature of 1 gram of material by 1 degree Celsius. That is the technical definition. So just basically how much energy goes into a substance in order to raise it 1 degree Celsius. Specific heat is one of these very specific things, pun intended, that is very indicative of any particular substance. Okay, it's like an identifying characteristic, just like the density, the boiling point, any of these standard physical characteristics of a substance. Okay, and if it's a pure substance like an element or a specific type of compound, these things are pretty much fixed. Okay, so a material with a high specific heat can absorb a great deal of thermal energy without a great change in temperature. And so from the chart you see here, what substance can absorb a lot of heat before it raises the temperature of water? Well, water itself. All right. So this is a number that you need to get familiar with. Right here. All right. Now notice what specific heat is measured in. Oh man, look at these. Specific heat's units are a joule per kilogram times degree Kelvin. Okay, so a couple things you need to be mindful of there. You need to remember what exactly a joule is, right, in the long form. And remember that Kelvin, sometimes if you're given information in Celsius, you will need to convert it to Kelvin. We did this earlier in the year, but it's just adding plus 273 to Celsius. Okay? So here's the equation for specific heat. All right, it looks scary, doesn't it? It's got a Q in it and a delta sign. Woo, scary. Q stands for the energy transferred, or in other words, the specific heat. All right, and is measured in joules. Okay, the energy transferred is measured in joules. Sorry, the mass of the water in terms of grams. The specific heat capacity. Now this is a constant. Okay, it's a constant. So like I say, each substance or element is going to have a specific, another pun, a specific fixed value associated with it. All right, it's a constant. We call this the specific heat capacity. So for aluminum, that is 903, okay, joules per kilogram times Kelvin, okay. Copper, 385, ice, 2060. Here's something to think about. Ice. Why is ice and water different? That's a good A-level question. I wonder why that is. See if you can figure that out. Let me know. And last but not least, delta T. All right. Delta, the triangle delta, sorry, put it right here. All that means is change. Delta T just means the change in temperature. So how do we find change in something? You just merely subtract it. Okay? So let's look at a couple of examples. The one last thing that I'll show you how to do, because you'll need to do this on your little quiz that you'll take here in a few minutes, is you need to learn how to find delta T. We did this in Unit 6 where we did acceleration, final minus initial. So that's how we do it here. So to find delta T, you just subtract the final temperature minus the initial temperature, right? So let's say the final temperature was 50 degrees Celsius. The initial temperature was 30 degrees Celsius. So in our word problems, it'll be written like this. It'll move from this to that. So you just have to pay attention to the verbiage, all right? And that'll tell you what to do. Remember, this number can be negative too, so be careful with that. You might have a surprise there waiting for you. So this particular example, delta T, man, that's terrible. Yikes. Is going to be equal to, here, let me do it better this time. Delta T in this particular case would be 20 degrees C. All right, so those are your examples of how to work these out. You have a little quiz over these, so go ahead and take that. Show all your work, show all 3 steps, just like we've always done. Good luck.